You might have believed that Tesla had achieved the highest level of performance, durability, and low-maintenance design. But brace yourself as they're about to raise the bar even higher. Elon Musk has recently unveiled their newest motor, and it's creating quite a buzz in the industry. Introducing the HairPin motor, a groundbreaking drive unit that's making electric vehicles even more competitive, not only against earlier EV generations but also against traditional combustion engines. Absolutely. We're introducing a motor that has the potential to revolutionize the industry, and we're about to explain why. Get ready for an exciting journey as we delve into the remarkable advantages of the HairPin motor, which has sparked widespread interest and discussion. Tesla, a company that has both critics and devoted fans, is undeniably making significant strides in the realm of electric vehicles. Their commitment to reducing costs and enhancing environmental sustainability has led them to employ software modeling for optimal configuration and a distinctive design that involves welding without rare earth minerals. As a result, they've developed a drivetrain featuring a $1,000 motor and a $5,000 battery pack, making their mass-market vehicle not only viable but also highly profitable. Brace yourself for the fascinating insights into this game-changing technology. Excitingly, Tesla has introduced a groundbreaking motor technology called HairPin motors, which stands out as a remarkable advancement in terms of compactness, weight reduction, and overall evolution. The most striking aspect of this engine is its HairPin motor fill factor, reaching up to 0.7, whereas conventional round wire motors typically achieve only 0.4 to 0.6 fill factor. This innovation leads to improved thermal performance and facilitates a highly automated manufacturing process. The new inverter design is another game changer, boasting a significantly more compact size, along with a cast-in-place high-voltage connector and a data connector. By removing the casted cover, one can witness this design firsthand. Tesla has gone the extra mile by optimizing the engine layout and enhancing the chiller assembly for even better performance. All these advancements represent a significant leap forward in electric vehicle technology. Using an innovative friction stir welding technique, they've assembled the components, resulting in an impressive outcome. Now, you might be curious about the engine's filter. Unlike conventional spin-on or user-replaceable filters, this one doesn't require replacement throughout the car's lifespan. Its purpose is simply to prevent small wear and manufacturing debris, thus eliminating the need for periodic changes. Before delving deeper, let's cover the fundamentals of electric motors. In electric vehicles, the battery's electricity is transformed into motion to propel the wheels. The latest Tesla engines have taken this process to an entirely new level by generating opposing magnetic fields in both the stator and rotor. This advancement marks a significant stride in electric motor technology. The rotation of the rotor is achieved through the interaction of the push and pull forces between the opposing magnetic fields. In the stator, the magnetic field is created by the flow of electricity through the copper winding. On the other hand, in the rotor, there are two distinct methods of generating the magnetic force. Permanent magnet motors rely on magnets placed in the rotor to establish a constant magnetic field, while induction motors induce the rotor's magnetic field using aluminum or copper bars. When these bars encounter the stator's magnetic field, they induce an electrical current, which, in turn, generates the rotor's magnetic field. Now that we've covered the fundamental principles, it's interesting to note that Tesla has been developing its own drive unit since its inception. This reflects their commitment to innovation and control over the design and performance of their electric motors. When Tesla introduced their Model S in 2012, they brought a significant revolution to the electric motor industry by developing their own in-house drive unit, eliminating the need to rely on technology licenses from third parties. Both their induction and permanent magnet motors are considered cutting-edge and highly efficient in the current market. The induction motor, conceptualized by the renowned Nikola Tesla in the 1880s, continues to be widely used due to its effectiveness. This motor operates by generating a rotating magnetic field using electromagnets, which induces an electric current in the rotor, resulting in motion. Tesla employs the permanent magnet motor in rear-wheel drive setups, while in dual-motor versions of the car, an induction motor is added to the front wheels. By dynamically shifting power between these two motors, Tesla optimizes efficiency and torque for various driving scenarios. In essence, Tesla's innovative approach to electric motor design has allowed them to create advanced and versatile motor technologies, elevating the performance of their electric vehicles to impressive levels. The motor excels in high-torque situations such as acceleration and hill climbing, while the permanent magnet motor shines in terms of efficiency, especially during highway cruising. However, Tesla has taken things even further by developing a new type of motor for their Plaid vehicles, like the Model S, Model X Plaid, and Tesla Semi. Known as the HairPin motor, it employs a unique stator winding using hairpins instead of round wires. The rectangular shape of hairpins optimizes the fill factor, utilizing space more effectively and resulting in approximately 20% higher efficiency. This innovative technology brings numerous advantages. The improved fill factor leads to a stronger magnetic field, enhancing rotor rotation and increasing torque at the wheels. With a smaller stator, copper losses are minimized. The optimized winding path simplifies assembly, and hairpin motors have reduced long-term failure risks. Moreover, hairpins can carry more current than round wires, resulting in less heat generated in the winding and motor. This simplifies temperature management, enhances reliability, and extends the motor's lifespan. Additionally, the symmetrical and solid shape of hairpins makes them easier to wind compared to round wires, contributing to the motor's overall efficiency and performance. Tesla's implementation of the hairpin motor showcases their commitment to pushing the boundaries of electric vehicle technology. The absence of stator lacing, a feature not required in hairpin designs unlike round wires, simplifies the assembly process significantly. With this groundbreaking innovation, Tesla has truly set a high standard in the electric motor industry, creating an exciting time for technological advancements. Hairpin motor designs offer a plethora of advantages over traditional round wire motors, including precise placement and a cleaner overall design. Notably, major automotive players like Volkswagen, BMW, and General Motors have already embraced this new trend. Despite its benefits, implementing hairpin technology comes with its challenges. Ensuring the accuracy of the bending and welding process for the copper hairpins is crucial, as even minor errors can lead to electrical losses. However, Tesla has surpassed these obstacles by leveraging custom software capable of modeling and simulating the entire motor, including its rotating electric field. This breakthrough allows them to rapidly iterate through millions of designs and select the optimal one, showcasing Tesla's next-level technology and commitment to pushing the boundaries of electric motor development. Tesla's distinguishing factor lies in its unwavering dedication to sustainability. Recently, they made a significant announcement regarding their next-generation motor, which will eliminate the use of rare earth metals. This move has caused a stir in the industry, as these metals are costly and essential components of traditional motors. By foregoing rare earth metals, Tesla stands to save substantial amounts in the long run, while also mitigating the environmental and social impacts associated with mining and sourcing these materials. Contrary to concerns about potential performance compromises, Tesla claims that these new motors will actually exhibit even higher efficiency and lower costs. This announcement has already had market repercussions, with rare earth mining stocks experiencing a decline after Tesla's statement. However, the greatest advantage for Tesla is the ability to scale up production more rapidly without relying on rare materials, a win-win scenario for both the company and the environment. YouTuber Engineerix provided an insightful look at this new motor design. Weighing a solid 194 pounds, the motor impressively delivers substantial power, an evolution of Tesla's previous drive unit released in 2017 for the Model 3. The new design boasts an all-new inverter, considerably more compact, and features an improved chiller assembly. Though some may see a potential downside in the non-user serviceable cartridge oil filter, it is designed to last the entire lifetime of the vehicle without requiring replacement. Additionally, the smart update of relocating the breather to the top of the casing enhances the motor's overall efficiency and manufacturing process. In essence, if water manages to reach the drive unit, it cannot enter the gearbox unless it passes over the breather naturally. As the YouTube video comes to an end, we want to express our appreciation for watching. If you enjoyed the content and want to stay updated on the electric vehicle revolution, please consider subscribing to the Electric Vehicle Revolution channel. Thank you for your support and stay charged up for more exciting content.